Is the slope of a line negative, positive, zero, or undefined? In this lesson, I will teach you how to look at a graph of a line and determine whether the slope is positive, negative, zero, or undefined. I want you to imagine standing on the far left side of a line. If you move uphill as you move from left to right on that line, then the slope is positive. M is the symbol that represents slope in a linear equation. If you are standing on the left side of a line, and as you move towards the right, you go downhill, then the slope is negative. All horizontal lines have zero slope, no slope. All vertical lines have an undefined slope. So in these two examples, this line is going uphill as you move from left to right on the line. This line is going downhill as you move from left to right on the line. So you always imagine standing on the far left of the line. If you're going uphill as you move to the right, it's positive. If you are going downhill as you move to the right, the slope is negative. If you do not go uphill or downhill, but remain flat on a horizontal surface as you move from left to right, then there is no slope, a slope of zero. When we're talking about a vertical line, the slope is undefined. There's no such thing as slope for a vertical line. So let me give you another way to think about this. If you are walking along a perfectly flat street, there is no slope, and therefore there's no stress on your body. Every step is the same stress. You pick your leg up, gravity's pushing you down. Every step is the same on a horizontal line. So there is no stress. It's zero for the slope of this line. But as you walk uphill, there is increased stress on you as the slope increases. So if we were to pull this point of this line down a little closer to the x-axis, the slope would not be as steep. The stress on you as you walked uphill would not be as steep. So slope increases as you go towards vertical. When you reach vertical, there is no such thing as slope because I can't evaluate walking up or down the side of a building. There's no such thing. I can't say how hard is it to walk up or down the side of a building. There's no such thing as that. So we can't evaluate it. It's undefined. Now, when we move past vertical, if we were to pull this edge of the line down, going back towards this x-axis, we're getting a graph like this as we pull this edge down. The closer it is to vertical, the steeper it is going in the negative direction. So it's going to be a larger negative number for the slope the closer the line is to vertical. But as you move this tip closer to the x-axis, the slope is not as large. It is a negative slope. It is a negative force with gravity pushing you downhill. Now this is the standard equation for a line. This M for a line that is moving uphill as you go from left to right has a positive slope, and therefore this M is going to be a positive number. This B is the location on the y-axis where the line crosses, right here. The y-axis, not the x-axis, the y-axis. That's this point right here. On this graph, we have y equals mx plus b. That's the standard equation for a line. The graph of this line moves downhill as you move from left to right. So this line has a negative slope. This m is going to be a negative number. This b is going to be the location on the y-axis where the line crosses, right here. Now the equation of all horizontal lines is y equals b. B is the y-intercept. B is the location on the y-axis where the line crosses. Horizontal lines have a slope of 0. 0 times anything is 0, so we do not have this term with the x variable. All we have remaining is y equals b. Y equals b. So the equation of all horizontal lines is y equals b, and b is the location on the y-axis where the line crosses. In this example, the vertical line does not cross the y-axis unless it lies on the y-axis. The way you write the equation for a vertical line is x equals something. Vertical lines are the only lines that have an equation x equals something, and that something is the location on the x-axis. Not like here where it was on the y-axis. This is the location on the x-axis where the line crosses. Now, if this line lies on the y-axis, this point on the x-axis is 0. So the equation would be x equals 0, or the y-axis. Because we have an undefined slope, so I can't even evaluate this because I don't have this. I can't just take it out. It's not a 0 or a 1. There's no such thing. So I don't have this term. And then there is no location where it crosses the y-axis unless it's lying on the y-axis. That's not crossing the y-axis, that's lying on the y-axis. So we don't have any of this. So the only thing we know is the point at which it crosses the x-axis. And that's why the equation is x equals something. So if I had a line and I wrote x equals something, you'd put a point on that line. And that would be the end of the graph. But because this is on a plane, I'm making a Cartesian plane, although I did not label the axis x-axis and y-axis. This is to be a Cartesian plane. So I must put a point at x equals whatever the equation says. And because it's on a Cartesian plane, it's just not a point on a line. So therefore, I have to draw a line through that point to graph it. I hope this lesson was helpful. Please leave a comment. Your comments help me improve the quality of these videos. No more math blues.